Thank you, and thank you for joining this session. We are going to talk about Corteva's portfolio of insecticides. As has been mentioned, we are going to talk about the modes of action. Other companies do not have these possibilities. This will enable us to increase and fight resistance. The line of products is called Natura Light. We hesitated whether to register it as a biological product. In fact, it is a biological product, and what was the case 30 years ago? Biologicals did not have good reputation for plague control or fungi control. The producer usually associated biologicals with less control. But these are products that have an excellent persistence and excellent power to fight insects. So this is Naturalite portfolio. It is a bacterium that grows in a sugary medium. There are many sporas were growing in that medium and spikes because there are spinoscides, and you can see the form of the bacterium here. As you can see in the chart, this is not a product that can be manufactured as the rest. It is a singular method where the bacterium is selected, then there is an industrial part. The most complex phase is fermentation. Then we have precipitation, extraction, and drying, and we reach the end product. If you were able to reach the end product without chemical intervention, we would have spinosad. With chemical intervention and with the J and L metabolites, we get spinetoram, which was our latest release. So what is our goal? We use less active ingredient per hectare, and it becomes much more stable, facing all kinds of environmental situations. We are going to talk about insecticides. Exalt, the slogan is the best tool for the control of Spodoptera frugiperda in maize. This is one of the plagues that is most complex to control worldwide, and it has many instances of resistance. We could draw an analogy with some weeds. It is a product that has high efficacy due to the power of destruction. When we are going to apply this in the field, we find a percentage that is already in L3. It is almost penetrating the maize plant in the fresh parts, and those insecticides that do not have good elimination power cannot control it. So it needs to have 2-week persistence. An insecticide needs to be persistent, and it has contact and ingestion. And it is green band class 4 with elevated selectivity, and we mentioned it is a Naturalite range. So this is an insect that can grate, defoliate, and eat. It is a cosmopolitan insect. In a few generations, if you repeat the same action or application, it can become resistant. So this is the damage that it can cause. This is how we show the activity of the different insecticides. The small L3 perforates. If you apply this with the larva within the plant, we will not get good results, and we will not be able to control the plague. What we need to take into account is, for all plagues, the temperature has to be taken into account. The higher the temperature, the lower the cycle. If I am in Rio Cuarto region with 25 degrees, L1 to L4, it takes 7 days. But if you go to the north of the country, in 5 days, with higher temperatures, you will get the larva inside the plant. And the companies and the technicians recommend apply the Davis scale. Davis scale number 3. When the leaf has been scratched to a certain degree. Sometimes we apply late at level 5 or level 4 when the leaves are perforated. This means that larva becomes larger, and they are ingesting green material. What I will show you is the study that we conducted at Iraq in the experimental station Obispo Colombres, measuring the susceptibility of this insect. We collected in different locations specimens of this plague. We sent this with maize leaves to the experimental station, and we had different cages. They were included in cages in pairs. On a daily basis, the postures were extracted, and afterwards, one larva of S. frugiperda was inoculated using an instrument, and these were inoculated with larvae from different locations. For each population, we evaluated almost 1,800 larvae, considering for each insecticide approximately 448 larvae. For each concentration of insecticides, we considered 4 repetitions. Each was represented by 16 L3 larvae. That is to say, with the 4 repetitions, a total of 64 larvae by concentration. And we also considered a witness specimen. This is a photo of the inoculated larvae with 1 larvae per cell. And here you can find the different ingredients. We had concentrations, and what we can see in the red circle is the dosage on the field with 3x and 8x.
We took 5 places, one in the northwest in Salta, and what we can see there is that products such as chlorantha, luferuron do not have a percentage of control that reaches 90%. What we can see is that the consistency of presentarán for that particular population. Another one in Tucumán. Here we repeat chlorantha, which does not reach 90%, and then of course lambda with lower values, and once again spinetoram shows very good control. Then in Chacabuco, we repeat once again chlorantha and lambda with low controls, and we have Excel with 100. We can see the dosage of 0.5025 have very good control levels. And when we go to Rio Cuarto, for example, in Córdoba, where the pressure of the plague is less and the applications of the rest of the products is not so much repeated through time, they are all over 90%. This says that this is a difficult plague to get rid of, and as you repeat the same mode of action or the same insecticide, the plague manifests it and the controls are lower. And finally, Savalla in Santa Fe, everything is over 90%. Excel shows 1x for 100%. You can see the dead larvae of Spodoptera frugiperda in the dose of 1.1x, and the live ones with the sample with the letter B. So for each of the places, we can see what Chloranta managed to do with the problems that we had in the Northwest and the Northeast with frequency of use, lambda, maximum problems in Tucumán and Chaco, survival of lufenuron, where it was mostly used in the past in Salta and Tucumán, and spiretroran, with very good results in the 5 territories. And that speaks about the robustness of the product. The dose of Exal is 80 centimeters per hectare, and with that we managed to control the plague up until L3 larva stage with a persistence to control the plague of 14 days. We also have the active ingredient, which is in our product called Quintal Extra, which is an insecticide that we have for soy crops. This product has a very fast turnaround, excellent control of all of the lepidopters, and because it is blended with metoxy, we also have 2 modes of action. And therefore, for our care and the resistance, we have 2 modes of action that are not present in other companies, in other products. In this case, for soybean and sunflowers. This is the mixed of spinetroram with metoxyfenicide. And it is a product that acts on contact and ingestion. It is also a class 4 green band. It is a concentrated suspension that is very easy to blend with any other product that we may be using in the soy crops. As I was saying, when we began, it has a lot more activity due to the chemical modification that the molecule has. Spinosines are very, very robust when it comes to controlling thrips, which is a plague that has been around for about a decade and that has persisted in spite of the year being drier. The issue at the end is very important right now, which is this works independently of climate conditions. Many applications of chlorantranil and Prodi, a few campaigns before, they were saying we have resistance to it. It didn't work. And this was what was said, and it turned out that this was done at a point where the temperature was very much elevated. Everybody knows that that affects pyrethroids. But when temperatures go up from 30 degrees centigrade, it also affects iamides. And we could see that this did not work in soybean crops. The spinofines are completely independent, and even with extreme temperatures of 35 or 40 degrees, it can still work for the control of these lepidopters in soybean crops. These products have translaminal penetration, and this means that you have the leaf and the product penetrates up until half of the leaf, and this is important. It can become independent from the climate conditions, and it's also important to control plagues that sometimes we don't have that much here in Argentina, but in Bolivia and Paraguay, Sometimes we have plagues that eat from the inside out, and this product helps with that as well. The methoxyphenoside in the product is a simulator of grison. Entomologists say that this is within the products that affect the insect in its physiology. They are the only ones that act on this mechanism. The others are inhibitors of chitina. What happens when an ant eats this material? The level of a synthetic oxidase starts. So any insect to change, it stops eating, it changes its whole tegument. You have the apolysis, so it ends up with the X disease, which is the getting rid of the tegument on the stomach area. This transformation process begins with this insecticide because the insect is not ready for that. It can never get rid of the old tegument from its body, and therefore they unite, and by doing that it soldiers to itself, and the first thing that happens is where the mandibles are, so the insect stops eating. So if we were to observe a microphotograph of a larvae that has not been treated on the profile, and through the front we'd see the mandibles that are that can be seen, but with methoxyphenoside it can be seen like warts. This is the old tegument that has been sort of stuck on. So what is the difference of this? There is a velocity of use and control. If we go to the 5 stages of larvae, 1, 2, 3, 4, and 5 is done, and if it has 6 stages, can be controlled as well. The plagues that it controls is the whole complex of these defoliating insects, including Chrysodexis includens, a plague that is pretty hard to get rid of. There are many insecticides where we have to up the dose in order to be able to control it. Ratiplusia, Anticarsia, Helicoverpa, and the trips, which this product works on. I'm going to stop here a bit. The damage made by trips is not just because of the fact that they feed, but also in the rate of photosynthesis, which is very important. And when you have trips at some point on the lot of land, even though after a rain, the crop may seem recovered. I call it the silent plague because the producer normally doesn't see that it eats the leaves, so you don't really see the damage, and you see the damage at the end because the crop is a bit yellow, and there's nothing you can do. As agricultural engineers, we need to work on this plague. There's a lot to do with it, and there is a lot of things that we may recover with the products that work to control the trips. This plague can give us even 5 quintals with one application when the peak of trips is at its highest in the actual plot. What the producer sees, initially they are confused when you see the lot. From far away, it looks like drought. There are false expectations that the trip may die due to the rains, but it is not like spiders that they may die or have less population due to rains. Many people say there's a lot of trips, but the soil looks fine, and many times when they go back, the situation is already irreversible. So it is a silent plague that takes kilos from lots without the producer seeing it or being able to control it. How many kilograms of soy can we lose due to trips? It varies, and it depends on the population abundance. Camundi, who has worked on this clave the most in Oliveros, says that we can lose between 200 and 400 kilograms of soy, between 10 and 25%. They have. A while ago, Corteva has been working for a long time on testing on trips, following a protocol of Fernando Flores' thesis, where we took trips from the mid-strata of the leaf. We count them on the lab, and where we have a lot of trips, we go and we do the testing. The picture that you can see there is once we have taken the soy, you can see the infestation. I brought you the last two campaigns, a test that was done in 22-23 in the Peñaderos, where on the day of application, day 0, we had on average between 16 and 18 trips per lot. Each lot has 10 repetitions, and we take 10 samples from there, so the testing is pretty robust when it comes to sampling. And we tested this with our sample, and we put some products there on the testing. What I like to highlight is the turnover that the product has. This is a plague that any insecticide that can show me control of this plague is something that will show a favorable response versus the witness product. If you have trips, control it with something that may control it, because you'll get better yield. This Quintal Extra has shown that it is very, very robust against these type of plagues. When it comes to the crop, all of the products that have control will have a response in yield. Campaign 23-24 in General Dehesa, 13 to 14 trips per area, per sample. That was the population. A day later, same thing. The turnover of spinosines in this plague is very robust, and as you can see, when we go to crop time, it shows a higher performance. But also the ones that were controlled show more than the sample. Dosages and recommendations for use for Quintal Extra, it varies. 80 to 100 or 80 to 120, and that depends greatly, like all insecticides, on the size and the amount of these insects. If I have very few and they're small, the minimum dose is great. If I have a lot and they are small, the minimum will also control them. I have to go up in dosage as they are bigger if I don't want to see these caterpillars, to make the most of this intense application of the product. This product, in sunflower, for example, it works very, very well. We have registered for Ratiplusia, and we've seen that in sporadic areas it also works very well. And the second asset that I want to show you is Isoclast. We use it in both our insecticides called Expedition and Transform. Let us have an overview of Isoclast. It is an active that is very efficient to control sucking insects. It has the same translaminal action up until half of the leaf, but it has a systemic action It is like all insecticides from where the drop falls via kinematic way upwards. It has persistence and turnaround. And in order for you to understand, in sucking insects, you may think about the elliptera. But if we look at suborders, we have different types of insects, and what we do by controlling this product will be done due to the systemic nature of it, and because the insect absorbs it. Many of these have fantastic results. White fly, for example, before the prohibition of chlorpyrifos, we were testing it for aphids, for example, and this is a product that is a bit slower, but it gives us good turnaround for this. It is part of sulfoxamines, but we will see the differences in the group 4. The main advantage it has is that it degrades very easily in soil, and it does not have the persistence of a neonicotinoid, and the metabolites don't have the risks of other nicotinoids. And it is a green band insecticide, class 4, and the difference it has with neonicotinoids, it has different chemical structures. They bind in a different way to the receptor. The insect in the process of application and death has a symptomatology that is different. Insects that are resistant to nicotinoids are not to the sulfoxamines, because the insect, as everybody knows, in their body to defend themselves from attack, has enzymes that work in multiple ways, and one of them are the monoxygenases. If you apply a neonicotinoid, all of these will go and attack the insect, and they can expand them, and it degrades the product so quickly that it becomes resistant to insects. Although the insects may go up in monoxygenases, the mechanism does not act against this product.
This is simply to illustrate where the neonicotinoids join in the synapses process and where isoclast binds in a different site, which makes it unique. Within IRAC, they are classified as group 4, group 4C. This is the key takeaway for this presentation: the rapid degradation in the soil, the problems of neonicotinoids within the same group of classification. Examples. One, there are some, for example, the thiamethoxam can last 1 year in the soil. What can be the disadvantage, the microflora and microfauna of microorganisms that degrade herbicides in the soil? That is why it could have a higher carryover of those herbicides. The problem is this could be applied for soy bugs, but the product does not reach the soil. But when the leafhopper came, the recommendation was to apply early and reach the soil. That is why we need to take those problems into account. Here we can see the duration of neonicotinoids, isoclast. The active ingredient has very short duration in soil. In this chart, also, we answer the question why neonicotinoids of first generation came back to the market. Because they are less harmful than those of the second and third generation. It is very important to choose wisely. We are talking about the acetamiprid. Well, companies that do traceability, this product helps lower that harmfulness. Expedition is isoclast active. This is a product for bug control for soy, and it has an emergency registration for the leaf hopper for maize. The 4 main species that we have in soy, Nesara, Edesa, Piesodorus, and the Kelops. The important thing to note is that the label dose controls all 4 of them perfectly well. You know that the most complex one is the Kelops, and we need to increase the dose when it is present. Our label already includes excellent control of the Kelos species. This is what I wanted to show you regarding environmental risk versus other neonicotinoids. For bees, the problem is that the index rises. As regards isoclast, the index is much lower, and we are able to lower the environmental index considerably. There is one from the University of Buenos Aires, then there is another one from University of the US, so you can look up the index and see how it can be lowered. The dose goes between 200 and 250 centimeters, and we can control perfectly well all bugs. If there is one lot or plot that has only Nesara, the green bug, we can use 200 and we can control this perfectly well. We also have registration for peak bugs of the soy. You will get very good control of the plague. And as I mentioned previously, for Talbulus milis, we have an emergency registration where the control dose is 300 cubic centimeters per hectare. A very important note. Last year, we attended several presentations on this plague. Many entomologists were saying this plague has come to stay, and many of the biologicals companies had lots of biologicals in their storehouses or warehouses. The thing is, we need to understand compatibility, because many chemical synthesis products can kill the biological insecticide. Sometimes it is the active ingredient, and some other times it is the excipient that kills the biological. So we need to ask the company that supplies the biological whether it is compatible or not. For expedition, it is compatible, both with Bauberia and the other one. This is important for producers who want to do chemical synthesis with a biological. We apply this. You know, it is very complex to control the leafhopper. It is a lot of studies are necessary to be able to deal with this insect. They have an excreting apparatus that is full of particles that are almost very hard to penetrate. So we need to break that lipid layer that this insect has. That is why we apply a product that could have 70 or 80% control, but we do not exceed 30 or 40% because the product reached the body of the insect, but it wasn't unable to penetrate. This scheme allows us to demystify the old question that I guess get asked by university students and also by producers and technicians. If a sucker insect has its mouth in the product, if it is a systemic product, how can it be controlled? That contact, permanent contact, there is an exchange between the different parts, and there is a passage of the insecticide. So any insect that is being fed will also ingest part of the insecticide, and it will be controlled. This is the problem that Dalbulus dilis have. Our body is covered by drogosomes. These are microscopic grains or granules that are hydrophobic. They are produced by their tubes, which is their excretion system. They are excreted through the anus, then it is distributed throughout the body. These are nanospheres of lipids and proteins.
Lo que es cabeza.
You can look at the details of the head and thorax, how they are covered. So it's very hard to penetrate. We need to use something that will enable penetration. This is another insect that is covered in its surface. So insecticides, when there's nothing else to do, when the elimination of the green bridge is no good anymore, when I have already planted, or when the only alternative I have is using an insecticide, well, let us look into the combination of the insecticide with some support medium. Insecticides work in 30 or 40% of the cases on their own. So to conclude, that permeability between the membrane of the xylem and other parts enables systemic control of the plague. To conclude, I would like to say that Corteva is a company that is focused on continuous innovation. We have future releases that have already been planned. Kinraiza Active. These are products in our portfolio that will broaden our offering and will renew it, covering the sucking insects, the bugs, and aphids. We follow the criteria of low dosage, elimination power, and new modes of action, trying to rotate those modes of action so as to avoid resistance. And this is the main goal of our presentation. Another launch that we will have, it is now called Inc. 1. It is a broad-spectrum insecticide for lepidopters and coleopters. It is an insecticide that works by contact and ingestion. We are testing it on other plagues. And it has a new mode of action, different from group 28 and 30, with an excellent toxicological profile. And this is what is required all over the world. And this is my final slide. I have talked about insects. You may have attended some of the presentations dealing with diseases or weeds. All of this has to be included with good nutrition of crops that are being treated. This allows me to show integration and innovation that Corteva offers, introducing our brand to the company. This is always my last slide. You already know this. Some people say that this quote does not belong to Einstein. We are going to credit him with this phrase because he was a genius. he said, if you are looking for different outcomes, don't do always the same thing. In the field of physics and chemistry, which was Einstein's field, if you try the same methods, you will always get the same outcomes. This is not what we need to do. In plagues, weeds, and diseases, if you want different results, do always the same. And this is resistance. A different result would be control them. And this is my own phrase. Thank you very much for your attention.
Se las voy a contestar.
Now, if you have any questions.
Bien, acá hay una pregunta que dice, para que Quintal pueda controlar
For quintal to control Dalpulus, it has to puncture the maize plant. The product that we presented that controls Dalpulus is Expedition. The idea is to rapidly destroy the insect because Expedition has a very high concentration. Isoclast stays or remains in the plant. In the event there is an egg or a nymph that starts feeding, it would be controlled. We need to understand the percentage of insects that are infected. In the year of the disaster, 44% of the population was infected. In normal years, we reach 8, 10, no more than that. That is to say, every 10 insects, one or less than one may have the virus to transmit it.
Acá hay una pregunta que dice, ¿por qué Exal no está recomendado?
Why isn't Exal recommended for soy or alfalfa? For soy, we try to broaden the spectrum with the mix of methoxyphenoside. We try to broaden the modes of action so as to have a product that will last more over time in terms of resistance. So companies try to cement different products for different crops.
Herramientas y
Tools and strategies for loss of teje. Loss of teje is a plague. The main thing to consider is monitoring. It generally dies quite easily when you have a good application of most insecticides. What you need to take into account is that there is no explosion in the population, because in a very short period they can conduct a major defoliation. There are some lots that are rented late and they have weeds, because these insects can live in different weeds. So what we do is we dry out and we sow. So this insect causes a lot of harm in a very short period of time. The more they eat, the more they defoliate. So we need to eliminate the insect. Intellectra eliminates this insect, and this is a plague that is relatively simple to control, but it is a matter of monitoring. It is easily controlled with monitoring. I believe I have one more question. Two more questions. So this is the same question I read. Okay, and these were from the previous talk. So that's it. There being no further questions, I would like to thank you again for your attention.